Okay, if you are in Math 7, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are reviewing Lesson 6.4, Examples 1 through 3, and they can be found on page 268 to 269. Okay, before we left on break, we were working with tables and trying to determine whether tables were linear or nonlinear. Now remember, every table we give you at this point is a function. Everything we're giving you is a function. So you don't have to determine whether it's a function or not. It is a function. You can assume that everything we're giving you is a function. But we do need to determine if it is a linear function or a nonlinear function. So the book will give us a table that looks like this: 3, 4, 5, 6. 1, 2, 3, 4. So the book will give us a table like this. In this case, the table is horizontal, but it can also be vertical. And to determine whether this table is linear or not, it is a function, but we want to know, is it a linear function or not? We need to look for patterns. So from 3 to 4 is +1, +1, +1. So far, that looks like a pretty good pattern. It's constant. This is a constant pattern, +1, +1, +1. Now let's take a look at our y's. +1, +1, +1. Oh, look at that. So as x increases by 1, y increases by 1. We have a constant rate of change. My pattern is constant. Therefore, this table represents a linear function. It is linear. Okay, let's take a look at another one. We have our x's and our y's. 2, 5, 8, and 11. 4, 7, 12, 19. So we're giving you this table, and you can assume it is a function. We want to know, is it linear or nonlinear? So we're going to look at our patterns. +3, +3, +3. Okay, let's take a look at our pattern for y. +3, +5, +7. Okay. So as x increases by 3, y increases by different amounts. So this is not a constant rate of change. This is not constant. +3, +5, +7. Not constant. Therefore, this is a non-linear function. Okay. So this is review for tables. If it has a constant pattern, well, then it has a constant rate of change. It's linear. If the pattern is not constant, then it does not have a constant rate of change, and it is nonlinear. Okay, let's take a look at graphs. The book will give us a graph that looks like this. Okay. And remember, the definition of a line means that it's straight, right? This is not straight. The graph is not a line. It's not straight. The graph is not a line. It's not straight. Therefore, it is non-linear. I think that one's pretty straightforward. So let's take a look at a couple of other examples. Okay, here. Y equals -1. That looks like it's a pretty straight line to me. We have a positive sloping graph. Looks like it's a straight line to me. In both of these cases, the graphs are lines. They are straight. Therefore, they are linear functions. I think that one's pretty straightforward too. Okay, the last ones. Okay, now we're going to look at equations and try to decide, is the equation linear or not? Remember, the equations we give you are functions, but we want to know, are they linear functions or nonlinear functions? So, y equals 3x. Now remember, a linear equation, slope-intercept form looks like this. Y equals mx plus b. Does this equation, can we write this equation, y equals 3x, in slope-intercept form, y equals mx plus b? So take a look at this. Is this written in slope-intercept form? Well, yeah, because remember, some people asked, well, what about the plus b? Well, where's the plus b? Well, if it's plus 0, we don't write plus 0. So if the plus b is missing, that means it's plus 0. So is this written in slope-intercept form? Yes. You can write this in slope-intercept form. You can write this in slope-intercept form. And remember, slope-intercept form is y equals mx plus b. Therefore, this is a linear function. Okay, well, that's dandy. What about this one? Y equals 4 times x minus 1. Can this be written in slope-intercept form? I don't know. We're going to have to rework it a little and see what happens. So how about if we multiply this out? How about if we distribute this? 4x. 4 times negative 1 is negative 4. Oh, would you look at that? Y equals mx plus b. Can this be written in slope-intercept form? It most certainly can. You can write this in slope-intercept form, which is y equals mx plus b. Therefore, it is a linear function. Whatever numbers you plug in here, it will form a line. Okay. Let's take a look at this one. Y equals 4 over x. Can we write this in slope-intercept form? I don't know. Let's see. Let's see if we can rework this. Y equals 4 over x. I need to get it to look like y equals mx plus b. So how about if we get that x to the top? What I do to one side, I must do to the other. xy equals 4, because these guys cancel. I need y by itself. I need to get y by itself. I need to isolate y. So to do that, I need to get rid of this times x. So I need to divide by x, y equals 4x. You know what? I don't think I can get this into y equals mx plus b format. It's kind of stuck like that. It's stuck like that. This cannot, be written in slope-intercept form. Therefore, this is non-linear. Okay, I've got one more for you. Y equals 4.7. Can y equals 4.7 be written in slope-intercept form? Does this form a linear function or a non-linear function? In the chat, I want you to type linear or non-linear. So take a look. Y equals 4.7. It is a function, but can it be linear or non-linear? I want you to type it in the chat. Okay, it looks like the majority of you guys are telling me this is non-linear. Let's graph it. Let's graph it. So this is my x-axis, this is my y. Y equals 4.7. 1, 2, 3, 4.7 would be about right here. So here it is. It looks pretty linear to me. Remember, y equals 4.7. When we do this, we have y equals 4.7. We need it to look like y equals mx plus b. Remember, when we have a flat line, the slope is 0. The slope is 0. Therefore, m is 0. If m is 0, x is 0. Remember? So anything times 0 is 0. So if the slope is 0, my m is 0. That means x is 0, because anything times 0 is 0. So what we really have here is y equals, this is 0x plus 4.7. 0x is going to be 0. 4.7 is your b. So can this be written in slope-intercept form? Yes, it can. Just like up here, when b is equal to 0, we don't write it in. So down here, the slope is equal to 0. Therefore, x is 0, because anything times 0 is 0. So can this be written in slope-intercept form? Yes, it can. You can write this in slope-intercept form. It made a straight line. Therefore, it is a linear function.